Example number 2. As I mentioned in the previous example, if you watch that one, there are two different things that we could do using cosine law or law of cosines. Number one, we could find a missing side given the angle that is between two sides. Okay. The second thing that we can do, and that's what this example is going to take a look at, is using three sides to solve for an angle. Okay, so in this case here, we're given three sides of a triangle, 10, 20, and 19.5, and we're asked to find what is this angle right here. Again, law of sines will not work because we're only going to have one piece of information per ratio, so we cannot use law of sines. Therefore, we must use law of cosines to solve for this. To start with, I'm just going to label the triangle here. So I'm going to call this A, this one B. Actually, you know what? I'm going to switch this. I'm going to call this one C because I want to show you that things can be mixed up a little bit. And this one A. And we're going to want to try to find big C here. And so this is little a, this is little c, and this is little b. All right, now the law of cosines, which involves these three, okay, is going to be the one that has angle C in it, and side C is going to be on the outside. All right, so it's going to be this one right here. So this one right here is the one that we're going to use because we're trying to find cos C. It's the only one that has angle C in it. So we're not trying to find cos C, we're trying to find angle C. It's the only one that has angle C in it, and it has all three sides. We are given all three sides. Now the thing is, we want to try to find what is angle C. Okay, we want to try to find angle C, but angle C is buried in this whole mess. So before we actually put any numbers in there, I want to show you how we can manipulate this formula to solve for angle C. First thing we're going to do is we want to get rid of these things that are adding here. So we have an a squared, so we're going to subtract a squared from both sides, and we have a positive b squared, so we're going to subtract b squared from both sides. And I'm going to do that from this side as well, and subtract b squared. This is where this program becomes a little bit of a hassle because it's tough to write things in. But now that I have that, what it's going to look like, and so again, this is just manipulating our formula to be able to solve here. I'm going to have c squared minus a squared minus b squared is equal to, and now here's a very important thing, it's a negative 2ab times cos of c. Right? So we're left with this negative 2ab times cos of c. Again, we're still trying to get c all by itself because we're trying to solve for that. And so the next thing we need to do is get rid of this negative 2ab, which is being multiplied to cos, to cos c. So I'm going to divide this side by negative 2ab, and I'm going to divide this side by negative 2ab. Now again, I'm dividing the entire side by that. And when I do that, let's use a different color here. Okay, what comes up is c squared minus a squared minus b squared over negative 2ab is equal to cos of c. And now we can solve for cos c. In this little equation here, if we know all three sides, we can put that in here, and that's going to give us what cos c is. Okay? And we can then use inverse cos to solve for c. If it helps, if it is of any help to you, you can also think of it as we can put the inverse cos in there. So we can also write this as, and I'm going to put the angle in front instead of in behind. Angle C is equal to cos negative 1, of, and let's do c squared minus a squared minus b squared over negative 2ab and close brackets. All right, there's a lot of brackets in there, and it looks like a little bit of a mess here, but what we need to do is we do the inside here first, okay? C squared minus a squared minus b squared, and then we divide that all by negative 2a, ab, it equals, and then we take the inverse cos to be able to solve for what is angle C. Now, if you're okay with using brackets on your calculator, you can just plug the brackets in, and that will give it to you as well. But this is a manipulated formula to solve for an angle if we're given all three sides. Okay, and that could be very helpful. It's just manipulated around. Now the thing is, we could do this for any angle, depending on what angle we're going to use. If whatever angle is here, so in this case it's C, that letter is going to be here. The other two sides are going to be seen twice. We're going to subtract by them, and then we're going to multiply on the bottom. If this was A, we would have little a here, and then we'd have B and C, and we have B and C on the bottom there as well. Now that we have that, let's actually go through and solve for this triangle, and I'll show you how we would solve for angle C. We're trying to find angle C. I'm going to use this one here. I just find it a little easier. We'll take the inverse cos afterwards. We'll do cos C, and let's get the formula here. Cos C is equal to, well, we're going to use this exact here. So I'm just going to plug in all of my values. Now you'll notice that I always open up a set of brackets, and that's actually pretty key, and I'll explain why in just a little bit. As negative 2 times, what was this, A and B, so 19.5 and 10. All right, I do a set of brackets because whatever's on top, we have to make sure that we do first. Okay, and if you just punch this into your calculator as such, okay, just type it all in without the brackets, it's actually going to give you a wrong answer because it's going to say that the negative 10 squared here is actually going to be divided by this, and then we're going to do all the subtracting. So it gives you a really big number, and often it's going to give you something you can't actually solve for because it'll be greater than 1 or less than negative 1, which might actually be the case as well. Maybe, no, not quite. All right, so let's solve for this using our calculator. I'll show you how to type this in, how I'd like you to type this in. All right, open a set of brackets. That's the first part. 20 squared minus 19.5 squared minus 10 squared. And why do I keep hitting the space bar? All right, so we start with that there. We put that into brackets. Okay, always put that into brackets. If you want to solve for it first, you can do that. You can gladly solve for it first and then go through the process of dividing. But we can also just put it into brackets and then we divide by negative 2 times 19.5 times 10. Now you can put that into brackets as well if you would like, but you don't have to. That it'll recognize. Actually, no, sorry. Yes, you should put that into brackets. I should have done that. I'm gonna have to do this again here. Sorry about that. Negative 2 times 19.5 times 10. Yeah, so we want to put that into brackets because we want to do the bottom piece as well. When we hit enter, we're going to get some sort of decimal value. Okay, and so we're going to find out that cos of C is equal to 0.20576,423, and then a whole bunch more decimal places. It keeps on going on and on and on. To find out what C is, we have to take the inverse cos of both of these. And so then we know that angle C is equal to, we're going to do inverse cos of our answer, 78.13 degrees or 78 degrees. So we can do 78.13 degrees, or angle C is equal to 78 degrees. Okay. So once you know angle C, we can then use angle C to find B using sine law, or we can use cosine law to find big B using little b as our initial one. And so we can kind of use other things. Once we know big B, we can find A using the triangle property, that all three angles have to add up to 90 degrees. Okay. Important thing, use this equation right here. Write this one down. Okay. We can manipulate it. You can put big A there and little a here and then BC, or you can do big B, put little b here, AC, and on the bottom would be the same thing. So important to remember that relationship of how it is set up.